So for initial contact, which is 0% of the gait cycle, we have 20 degrees hip flexion, 0 degrees at the knee, 0 degrees at the ankle. The ground reaction force is anterior to the hip and the knee axis of rotation and posterior to the ankle axis of rotation. Due to these ground force reactions, there is concentric hip extensor activation, concentric knee flexor activation, and eccentric dorsiflexor activation to go into the next phase. For foot flat, which is 0 to 8% of the gait cycle, we have 15 degrees hip flexion, 15 degrees knee flexion, and 5 degrees plantar flexion. The ground reaction force is anterior to the hip, posterior to the knee, and posterior to the ankle axis of rotations. Due to these ground reaction forces, there is concentric hip extensor activation, concentric knee extension, and concentric dorsiflexion to go into the next phase. Next is mid stance, which is 8 to 30% of the gait cycle, which is 0 degrees at the hip, 5 degrees of knee flexion, and 5 degrees of dorsiflexion at the ankle. The ground reaction force is posterior to the hip, anterior to the knee, and anterior to the ankle axis of rotations. Due to these ground reaction forces, there's eccentric hip flexor activation, eccentric hamstring activation, and concentric plantar flexion activation to go into the next phase. For heel off, which is between 30 and 40% of the gait cycle, there's 15 degrees of hip extension, 0 degrees at the knee, and 0 degrees at the ankle. The ground force reaction is posterior to the hip, anterior to the knee, and anterior to the ankle. Due to these ground force reactions, there is eccentric hip flexion contraction, concentric knee flexor activation, and concentric plantar flexion to go into the next phase. The next phase is toe off, which occurs between 40 to 60% of the gait cycle. There's 20 degrees of hip extension, which is the peak hip extension during the gait cycle, 30 degrees knee flexion, and 20 degrees plantar flexion, which is peak during the gait cycle. The ground force reaction is posterior to the hip, posterior to the knee, and anterior to the ankle axis of rotations. Due to these ground force reactions, there's concentric hip flexion, eccentric knee extension activation, and eccentric plantar flexion activation to go into the next phase. During the acceleration phase, which is 60 to 75% of the gait cycle, there's 20 degrees of hip flexion, 60 degrees of knee flexion, which is peak knee flexion, and 10 degrees of plantar flexion. There's no ground force reactions during these swing phases. So there's concentric dorsiflexion, eccentric knee extension activation, and concentric hip flexion. During mid-swing, which is 75 to 85% of the gait cycle, we have 30 degrees of hip flexion, which is peak hip flexion, 30 degrees of knee flexion, and 0 degrees at the ankle. There are no ground force reactions, and this phase occurs due to passive processes from the acceleration phase. The deceleration phase occurs between 85 to 100% of the gait cycle, and we see 30 degrees of hip flexion occurring, 0 degrees at the knee, and 0 degrees at the ankle. There are no ground force reactions occurring here, and we have isometric dorsiflexion, eccentric knee flexor activation, and eccentric hip extensor activation. Here is an example of it all put together. For the frontal plane, we see adduction of the hip of 5 degrees during the first 20% of gait, and then we see 5 degrees of abduction during 60% of the gait cycle. We'll also see eccentric hip abduction during the 20%, and we'll see concentric hip abduction during 60% of the gait cycle on that same side. And here's an example from frontal plane of walking. For the steppage gait abnormality, we're going to see an increase of hip and knee flexion to compensate for the fact that there is a lack of dorsiflexion in the left leg, as you will see right now. For the ataxic gait abnormality, we're going to see a wide base of support as the subject starts to walk.